Have a Mastertech inverter condenser unit. The other side was mashed up in the last video. So let's open it. Let's see what we can learn. As I said, this is dead. The board that communicates has an error, and there is really no way to actually get a replacement. It's not worth it. I'll take a closer pic of that so we know what the capacities are. First glance inside, we have the coils wrapping around, as you could have seen from outside. Obviously we have the compressor somewhere down there which you can't see properly. We have the fan here to draw the air through for the cooling, and the motor, a frame on which that is attached, and then this board, some big capacitors, some big inductors. I assume this is the inverter section, all included here. So let's make a little bit more progress and see what else we have. Electrical connection at the top, gas at the bottom, and we have the wiring diagram here. Again, I'll take a good pic of this. We've made some more progress. As you can see, fan is off, the insulation is fully off, or some attenuation actually, and the board is hanging on the side. I just want to see where it's connected. There's sensor on the back here where one of these is the sensor for the temperature. There is this device from a transformer company. It was mounted here, but it only has two contacts, so that has to be an inductive coil. It can't really be a transformer. Don't think it can, because you really need an in and an out. As I said, still don't know what those little things are, but we are much closer to being able to pull everything off. We have these two valves here. One valve goes to this fine coil that's wrapped in this tacky material with not really a silver backing. I don't know, that doesn't look like thermal insulation. I don't know why it's wrapped in this. Some form of protection at least. It goes in on this side of the coil. The coils go around. I'll take all these sensors. These are some good I suspect type K thermocouples. And this, what I initially thought for the inverter technology, maybe it was DC. It isn't actually. It's clearly 143 volts at 120 hertz. That's the operating parameters set there. Obviously it goes up and down. No point in having an inverter if you don't do that. 410, so that tells us what refrigerant we're working with. I really suspect this is a solenoid valve here. Can't see that being much else. As I said, a few different thermocouples, not that much more. If this is an AC motor running at 143 at 120 hertz, there's no way I can use that for anything useful, short of me basically powering up that board and figuring out how to run that. And I've already pulled out everything sort of without a plan, without really intending to put it back together. Nor am I really interested in trying to put this whole thing together. So I think what I will end up doing is cutting the wires, seeing if there's anything useful, else just leaving the rest of it for scrap. Really don't have the facility here to cut open my compressor, and again I cannot run that properly. I mean, I would be able to run it at maybe 120, 50 hertz through a transformer, 240, 50 hertz, but I would probably burn it. Probably can't use it, so probably can't do anything else short of cutting that open and seeing how it's designed. There is not much else I can do. Well, I've gone one step further. While it wasn't really useful, I think I still want to investigate the piping, so I've taken this out and I'll have a little bit more look and this deeper look at some point in time, but that would not cover on this video. And then I've scrapped everything down to frame, just the thing, and the coils. What I want to do is just quickly investigate how the coils were put together. There's two connected here coming in, one out. Just how they did it. This is just a brace, so just to see how they did it. Well, it's a little bit on the weird side. So you have the two coming in, it goes down, comes around, jumps over and goes on this one. This is the return from this, come to the front, that goes to the back, then they continue normally, then it does a jump again, so one from the front goes to the back back comes to the front. They've continued again, just jump in, front and front, back and back, right? Because it's two separate coils, right? It's one coil here and one coil there, which you can see from the separations. Then join the two of them together here. This is just a temperature sensor here. That's a basic couple, that's a temperature sensor. This is just a piece of bracing, right, to keep that pipe stiff. And they've gone singly now, and then back here. It's a bit odd. Not really sure why.